Now that you have a basic understanding of the high-level models, let's take a look at some of the specific ones you need to know for the exam. We start out with Bell-LaPadula. Bell-LaPadula is only focused on confidentiality, and it is mandatory access control. It was developed by the U.S. Department of Defense, and it is a state machine model. It is only focused on keeping our secrets secret, confidentiality. It does not care about integrity or availability. I personally have never seen it implemented, but that could be because of the military applications. For the exam, just know that it is mandatory access control, that it is only focused on confidentiality, and then these three properties. The simple security property states you cannot read up. Very simplified, someone with secret clearance cannot read top secret documents. No read up. Then we have the star security property, which is no write down. Here, subjects with top secret clearance cannot write to secret folders. Again, it makes sense. We don't want someone with top secret clearance sharing that information with people who only have secrets. And then finally, we have the strong star property. No read or write up and down, which means that only subjects on that specific level can read whatever information is at that level. And which property we choose to implement depends on what we are protecting. And now that we have covered Bell-LaPadula, let's look at BIBA. BIBA is also mandatory access control, but the whole purpose of BIBA is data integrity. It does not care about confidentiality. It does not care about availability. BIBA was also developed by the US DoD, and it is a state transition model. BIBA also has three properties or axioms, but remember the focus is integrity. The simple integrity axiom is no read down. An example of this could be people with top secret clearance cannot read secret information. Not really because we care that they have access to the data, but more because we don't want any lower level wrong information to confuse people or to influence them if they have higher clearance. Again, it is integrity. The star integrity axiom is no write up. Subjects with secret clearance cannot write information to top secret folders because we don't want their lower level inferior knowledge to influence and propagate to higher levels. And then finally, the invocation property. No read or write up. Here again, we don't want subjects on a lower level to influence or change data on a higher level. So BIBA, integrity, mandatory access control, state transition model, and then the three axioms or properties. Which then brings us to lattice-based access control or LBAC. This is also mandatory access control. And this is what I talked about earlier when we covered clearance. You don't just have top secret clearance. You have top secret, nuclear, submarine, something, something. If you look on the graphics over here on the right, you can see why it is called lattice-based access control. Because it kind of looks like a lattice that you would have in a garden or in a fence that you would have plants growing up. And these, in reality, are much, much more complex. There can be thousands of different options in that lattice. But for the exam, just know what they are, that it kind of looks like it does over here on the right, and that it is mandatory access control. You may also hear it referred to as label-based access control. Lattice-based access control was first formally defined by Dorothy Denning in 1976, and the reason I mention her is because first off, she's an awesome information security researcher, and secondly, she was also part of the Graham-Denning model, which is the next one we're going to cover. The Graham-Denning model uses objects, subjects, and rules, and it has 8 rules for access, objects, and subjects. A subject can transfer, grant, or delete access, read, create, or destroy an object, and then finally, create or destroy a subject. It is commonly used in distributed systems, and that is probably the extent you need to know about it for the exam. That then brings us to HRU, Harrison, Russo, and Ullman. It is based on and an extension of the Graham-Denning model, and it is an operating system level security model that focuses on the integrity of access rights to the system. It is based on the idea that a finite set of procedures should be available to edit the access rights of a subject on an object. And unlike Graham-Denning, it also considers subjects to be objects. The first 4 of the primitive operations should be familiar: create object, create subject, destroy object. The last 2 are, however, new: enter and delete rights from an access matrix. As you can tell by now, with these security models, you don't need anything in depth, but you need to understand how each of them work and be able to spot the keywords. And with that, we are done with this lecture. I will see you in the next one.